Hello, everyone, and a warm welcome to today's webinar session. It's perfectly 10 a.m., so we're going to get right into the topic on time. Just a quick hello. We will leave the camera on for the introduction, so you have a face to the name. Afterwards, we will turn it off so we can really focus on the presentation and the contents we are about to present. All right. So today's webinar is about saving energy with KNX weather stations, and it is actually part 2. Yesterday we held part 1, and if you missed that, you just need to be patient for a couple days, and we will upload it to our YouTube channel so you can also have a look at the first session if you missed out on it yesterday. A quick disclaimer, today's webinar is live, so we are really looking forward to get as many questions from you as possible. We would love to make this as interactive as possible. Let's get into it. We are your speakers today. My name is Bastian Elsner. I'm managing partner at Elsner Elektronik, and my responsibilities mainly lie around marketing and sales and also product development. Next to me, I have another colleague.
Yes. Welcome from my side. I'm Martin Speer. I'm delighted to be here today as a product manager. I deal with the requirements for our products on a daily basis. As an interface to almost all parts of the company, I know the needs, advantages, and disadvantages of our products. And as a long-standing system integrator, I'm particularly familiar with the user perspective from practical experience. So if you have any questions after that, don't hesitate.
Wonderful. Now, first, an introductory slide. You might remember from yesterday, I've seen some familiar names in the audience. When I have a look at a facade like this, the first thought that comes to my mind is we must have an insane heat input from the sun on the glass facade. But not only this, if we do not shade, we will require a very high cooling capacity of air conditioning systems to cool down the building to a comfortable temperature for all the users. Also, no glare protection available, and the heat load in rooms will be high, and that will lead to high cooling costs. We actually have a solution for just that. Today, we want to discuss about automatic shading and how to set up automated shading with a smart system, for example, with the KNX weather station. In my opinion, this gains more and more important. If we're talking about CO2 pricing that are going to be increased, it's good to be energy efficient in our buildings. We have global challenges like climate change and energy prices rising all over. This can be a part of the solution. In summer, we want to have a reduction of direct sunlight, and we want to reduce the operation of air conditioning systems. We're doing this in order to save cooling energy and to have an advanced glare protection for a higher comfort of the users of the respective building. In winter, it's just the other way around. We want to let the sunlight in when we require it. This can help us to achieve passive solar heat gains, which will then limit the heating energy required. And also, we can have the glare protection in winter. Let's see what we are about to learn in the second session of our weather station webinar. So after this session, you will know how to fully implement a comprehensive shading control system. You will know what levers you can use to save an energy through intelligent sun protection and how to supplement the system with additional facades. As mentioned, this is part 2. Yesterday, we discussed the basics. If you missed out on that, do not worry, we will upload it to our YouTube channel in no time. Let's have a look at the agenda. First up, Martin will take you to the model comparison and the function overview. Afterwards, we're going to have a look at the function and the special features of our Suntracer KNX Pro, our most complete weather station. And afterwards, we will have a deep dive into the ETS. Therefore, we will have a look on how to set up the facades, how to configure the facade automatic sun shading system, how to configure shadow edge and sled tracking, and how to do the fine adjustments of the optimum sled position so you can let the sweet little sunlight in order to reduce the artificial lighting and therefore another lever for energy efficiency. Afterwards, we're going to have a look at the protective functions. For example, how to integrate additional wind sensors if you have a big object that you're trying to automate, or further safety functions like the frost or rain alarm. Next up, we're going to focus on the energy saving and what kind of parameterization we need to do in order to achieve that. Next up, the installation and common troubleshooting, and afterwards, the integration of additional facades. We're gonna get right into the first agenda topic, the comparison of the KNX weather stations.
Okay, I would like to start with some general information about the differences between our weather stations. And so we divided them in 3 categories. The first one, or the first product for it, you can see the Wind Dancer KNX on the left-hand side. The device has the same functions as the Suntracer SL Lite. The novelty is that the wind measurement of the device is carried out via wind wheel and not electronically. The second one, it shows the P03 KNX weather station, which is the smallest version of the KNX weather stations. The device does not contain any facade automation or logic functions. With this device, only the measured values can be sent to the bus, for example, to a building management system. In the middle, you can see the Suntracer SL series. We offer these in the Suntracer SL, Suntracer SL Lite, and SL basic versions. We take a closer look at the differences between the individual models on the next page. The picture on the right shows the largest version of our KNX weather stations, the Suntracer Pro. This has facade automation for up to 12 facades. The special feature of the weather station is that it can detect the wind direction, and many, many more. Okay, now we come to our mentioned categories. You can see now a comparison of the weather stations, and this is only an extract. So on our website, we have a huge PDF where you can see any weather station of us and every weather sensor. And so it's easy to have a nice comparison between the weather station to choose the right ones. But of course, this webinar is to help you. So first of all, we divided them in 3 categories. So the category 1 is about separate facade control and measuring sensor. I can see our PX8 and the P04. Then the category 2, the details come on the next slides. It's about facade automation that can only be realized via logics. And the third one, these weather stations have integrated facade control. Okay, now we have a closer look to our Suntracer KNX Pro. Okay, here you can see the temperature sensor. Of course, we have the wind speed, and special here on this Suntracer KNX Pro, we have the wind direction. It's made by ultrasonic measurement. We have the brightness from all direction and the sky. We have the air humidity, rain, precipitation. We have air pressure. And of course, we have the GPS reception to calculate our sun protection and make a briefing shading. Okay, the special features of the Suntracer KNX Pro. As mentioned before, we can automate 12 facades. We can display the perceived temperature via KNX. The wind measurement is wear-free with ultrasound. The output of the wind direction is in degrees and text form, as well as the air pressure in HPA and text form. And if you have a closer look on the parameters in the ETS, you can see that many values are sent by text form. So it's perfect for a building management system to get the different texts. Okay, the programming is via magnetic push button. Now I'm heading over to Bastian again.
Perfect. Thank you very much, Martin. I have just realized some questions popped up about the comparison. So we just take a couple seconds to check those questions, then we will get back to you. Okay, thank you very much for the interaction. As mentioned in the beginning, I love answering the spontaneous questions that come up during the presentation, and one of them has been as followed. What do you need wind direction measurement for? This is actually a very good question. There are several use cases when wind direction is really important. So one reason, it has a safety functionality. If you think of a building that is starting to burn, you can detect from which direction the wind is coming, and you can close windows accordingly in order to limit the fresh air that is feeding the fire. So this is quite important for big commercial projects, that the wind flow can be limited, but therefore you need to know from which direction the wind is coming. Another feature that I got to learn on a fair just a couple months back is that in a small town here in the south of Germany, there's a big fountain, and around the fountain there is a person living, and he was complaining, if the wind is coming specifically from one direction, the fountain is pushing water into my garden. This fountain is not filled with drinking water, so this person has complained. The city only had the option to turn down the fountain when the wind was coming from one specific direction. They have used the Suntracer Pro and the wind direction measurement to achieve exactly that. There are many more use cases for the wind direction. If you would like to learn more about that, feel free to reach out and I can present some more use cases via email afterwards. Another question that came up was, when is it required to use a mechanical wind sensor and when is it required to use an electric one? This question has been asked yesterday already, and I will just make the same example. So if you have a single family home that has 1 to 3 stories, let me say, a mechanical wind sensor is perfectly fine and you don't need anything else. If you're trying to automate a shading system for a building that, let me say, is G+5, so ground floor plus 5 more stories, then it is required to have at every 3 stories, that's at least our recommendation, to have an external wind measurement sensor, and this one should be electronically, because the higher the buildings, the more likely it is that you have uplifting winds. Just from the way the sensor are designed, a mechanical wind sensor will never be as strong as detecting uplifting winds as an electric one is. Therefore, a rule of thumb can be, if the building that you're trying to set up automatic shading system is not higher than 2 stories or 3 stories, you can go for the mechanical one. It is higher than that, we definitely recommend the electric one due to the chance of uplifting winds. I hope that helped to answer the question. Once again, thank you very much for the interest, and we will continue with the presentation. Next up, we're going to have a look at the installation and the settings. So every building will need different types of shadings. And in this example, we will need one Suntracer KNX Pro and also one of our blind actuators. This is the basic equipment we would need for the automatic shading. So first up, in the following, we would like to set up a complete facade control system. The brightness, sun direction, height, and other parameters for saving energy on the building are configured in the facade control system itself. Next up, we will take a detailed look at how this can be implemented. Firstly, we're going to dive into the configuration of the facades. So I would now like to briefly introduce the functions of the facade control system. First up, we have the timers. For example, you can realize a timed opening or a timed closing. Next up, you have the night closing, the heat protection. You have the possibility of implementing a pyranometer for global radiation measurement. You can have the automatic rain control, and you can have the indoor temperature lock. One of the greatest levers for energy efficiency is the automatic sun protection. This is definitely what we're going to focus on during this webinar. Next up, you have the outdoor temperature lock. Later, we will cover a separate section with all the protective function and also have a look at the ETS for that. Those said protective functions are, for example, the wind speed, the rain, or also the frost, which I don't see mentioned here. A very basic facade structure of a building is a building with 4 facades as displayed here. But this is always the first step. You need to do the classification of the facades. So for automatic shading, first you must define how many individual facades the building can have. In this example, I will propose we keep it simple and just illustrate one of the most common types, a building with 4 facades. But even in buildings with a U-shape, which is quite a common misconception, people think there is more than one facade. But if you look here, according to this logic, we still remain with 4 facades. Keep that in mind. That is always the first step, also when choosing which weather station is required for your project. For buildings with an asymmetrical floor plan, or if they have a rectangular alignment, you will need more facades in order to control that. One example for this would be a floor plan that looks similar like this. For those buildings, we will have the facade 2, 3, and 5, which are the non-rectangular alignment. And we have the recessed facade 6, which definitely must be controlled separately. Curved and round facades can be also divided into different facade segments to make the automation as clean as possible. For the facade automation, we also need to define the orientation of the facade. The facade orientation corresponds to the angle between the north and south axis and the perpendicular to the facade. North, therefore, stands for 0 degrees. Alpha is measured in a clockwise direction. In the example, the angle is marked red here, is rotated by 30 degrees to the north. That means the alignment for facade 1 is 30 degrees. The other angles result from the angle alpha plus 90. That's what you can see on the illustration here. The other facade orientations are as followed. On the facade 2, you have the 90 degrees, so that means the alpha plus 90 degrees. On the facade 3, you have the alpha plus 180, and on the fourth facade, you have the alpha plus 270 degrees. And here we show the parameter of the facade alignment. More about that in the videos that will come up in a second. It is also possible that you will need to do the shading system for a facade that is actually inclined, as you can see here. So this illustration shows a facade with an actual slope, and if a facade surface is not aligned vertically, this definitely must be taken into account. An inclination on the facade front is counted as a positive angle. An inclination to the rear, as in the illustration, is considered a negative angle. If there is no inclination, the value 0 is entered in the following parameters. But in this parameter, of course, you can also adjust the inclination according to what your project is looking like. I have prepared a quick little video on how to do the configuration in the ETS, which we will show you in the following. Currently, we are in the application of our Suntracer KNX Pro, and in this video, I will show you how to set up the basic facade automation. So first up, we're going to go to the facades and we activate use facades. Now, below here, you can see all the global or general settings for each facade, but we do not want to go over those in too much detail. We just want to have a look at the configuration of one individual facade. So we're activating facade 1 and we move on to the facade 1 function and safety block. In this example, we would like to name this facade to our south facade. And we want to activate the slats. So I have a blind that has slats and that can be moved. Next up, we're gonna have a look at the automation. Here we can set up different settings, but we just wanna discuss the sun protection automation. So here we're also gonna hit the yes, and we can see the settings for the slat and shadow edge tracking in the solar protection position. So since we have blinds with slats, we want to have the shadow edge tracking and the slat tracking activated. As mentioned earlier, we are configuring the facade 1 as our south facade. So we take the value of 180 degrees as displayed here. If you have the north facade, 0 degrees, east 90 and west 270. And as mentioned in our example, we got to use the 180. The remaining features, we don't go over too much detail since we're going to discuss this later on in another video also. Okay, that was a brief little video on how to set up the facade. We will go back into the presentation. Do you have any questions about the facades or about the constants that we discussed in the last chapter? I will just wait a quick 10 seconds to see if any questions pop up, and if not, we will commence with the next topic on how to configure automatic sun protection for the facade. As said, I'll just wait a couple seconds. Okay, no more questions, so I think we can just go on. So the sun direction, also called azimut, is the position. So in general, the position of the sun indicates the area of sunlight on the facade. This area must be adjusted depending on the surrounding conditions. The sun area is already often restricted by, for example, neighboring buildings or vegetation, for example. As you can see in the following example, the building is already shaded by the trees, which are the green dots in the graphic. So as the sun rises in the east, that means that there is natural shading and the blinds do not yet need to be lowered at all. When the sun moves during the course of the day and the sun actually does hit the building unhindered, this is only when the shading provided by the plants is needed. So this sun area is therefore entered in the following parameter settings azimut. So for this setting, we offered a fixed area, for example, the south, east, west combinations. Individual adjustment of the ranges, of course, is also possible by activating the angle range. The individual sun areas can be entered in degrees. Next up, we're going to discuss the solar altitude or the elevation. So if we look at the height at the sun, in our example photo, the facade is shaded by the protruding roof when the sun is high. So shading is only necessary if the sun is low, approximately below 53 degrees below the roof. Therefore, you can set this up in the following parameters. The values entered in the green box correspond to the height of the sun in the parameter settings. For example, it could be 0 to 53 degrees, as mentioned in the picture. The brightness parameters are shown in the following image. So we can select whether we use the internal system or an external sensor system for another threshold value. The threshold value for the brightness, for example, 60 kilolux, can then be set. It is always recommended to also set up a hysteresis in percentage or kilolux. This can be selected falling below the threshold value. There's also corresponding delay timers. There's also corresponding delay timers for brightness control, for example, the extension delay or a short retraction delay or a proper retraction delay. A very easy example. So if the brightness limit value 60 kilolux is exceeded for 1 minute, then the shade is extended. For example, if there is a short cloud after this extension, so there is actually a short delay of the 60 kilolux, let me say for around about 10 seconds, then the slats can be opened a little bit just to let enough daylight into the room in order to limit the artificial lighting that we're using to have a comfortable brightness in the room itself. So, but if the value falls below the limit for 30 minutes, then the shading retracts again. Why do we do this? We do this to have a very calm picture of the facade. We don't want to overheat the engines that are moving our blinds, and therefore we use the retraction delays in all those thresholds. More about that in the next video. Okay, in the past video we set up the basic settings for facade number 1, and now we're going to have a look at the automation settings. Earlier we already said yes, we want to use the sun protection automation. Firstly, you can separate your facade into different ranges. So for example, if you have a neighboring building that is casting shadow on your building but only up to a certain height, then it is recommended to separate the facade, for example, into 2 ranges. For the sake of simplicity, we're just gonna remain with 1 range per facade in this example. Next up, we have the direction of the sun. The default value is all directions. Since here in this example, we only want to configure the south facade, we only trigger the direction of the sun south. How does this work? We have a GPS module in our weather station that can calculate the direction and the position of the sun according to the orientation of the sensors. This leads to that only if the lux value or if the sun is coming from the side that you want to shade, that actually this side is retracted. Next up, you can also have changed the position, like the height of the sun. You can take this into account also. For example, also if you have neighboring buildings or if you have some trees that cast shadow over the building, because if there's already shadow, you don't want your blinds to go down so you have no extra need for artificial sunlight. Next up, you have the brightness sensor selection, in which we can either use the internal sensors, which is then calculated the maximum value of our 5 integrated brightness sensors, or you can use it via a communication object from another brightness sensor. For this case, we're going to remain with the internal sensors. Next up, we can preset the threshold value for the brightness either with the parameter or with the communication object. So if you want to change the threshold value for brightness via a visualization, then you will need to use the communication object. In this example, we're going to remain with the parameter setting. Here we can set our threshold with 60 kilolux. This seems pretty good. Also, we can set the hysteresis here with 30%. Seems also good as the default value. Next up, we also have another really cool feature. This is considered travel delays, and that helps to make a very calm picture on the facade. So just a very small little use case. You have a big cloud moving past the building that you would like to shade, and this cloud is casting shadow and bringing the lux value down. This lux value has to be undershot by more than 10 seconds, otherwise no movement will happen. This helps if only a cloud is moving past, that your blinds are not moving or just the slats are moving, for example. In the next setting, you can also set the outdoor temperature block, but it's not really interesting for this use case because we just want to discuss the solar protection. Okay, now that we're done with our settings for the sun protection, we can have a look at the group objects and connect them accordingly. Since our Suntracer KNX has quite an advanced parameter structure, it's quite handy to use the filter we were using with the facade 1 earlier, so we can filter according to that. First up, we're gonna drag and drop the movement position to the movement position of our actuator, and we're gonna take the slat position and also drag and drop them onto the facade south slat position. And that's all we gotta do for connecting the group objects. All right, I hope you enjoyed the video, so we can get right back into the presentation. Before we hop into the next topic on how to configure shadow edge and sled tracking, I will give you the option of asking some questions. We will make a pause for a couple seconds, and if I don't see anyone typing, we will continue with the presentation. Okay, thank you very much. One very detailed question has popped up. This would need too much time to explain and go over this in detail, but we will get back to you via email. Okay, next topic on how to configure the shadow edge and the sled tracking. The desired shading function must be selected first in the automatic facade control. If you click the parameter, you can see the following option. You can either have without tracking. That means that the shading moves down in the sun and opens the sleds to a fixed value. You can also do this sleds in 4 levels. That means the sleds track the sun in 4 predefined values. Next up, you have the sled tracking, that the sled moves automatically with the height of the sun. Next up, we have the shadow edge tracking, which means that the shade changes the driving position automatically and adjusts it to the edge of the shade. And this is actually how far the edge of the shade can last into the room. The last one, and in my opinion the best and most advanced one, is the combination of shadow edge tracking and sled tracking. That means that the sleds are automatically adjusted to the height of the sun. That means we will let sun in when we can and limit artificial lighting need. Also, the shade changes in the driving position automatically and adjusts therefore the edge of the shade in the room. Now, the sleds and shadow edge tracking. If the sun protection needs to be there when the sun, So the sun protection when the sun is high. The sun shading is only partially closed and automatically lowered only far enough to prevent the sun shining further into the room than the maximum permitted penetration depth. The sun shading at a minimum medium sun position, for example, in the middle of the day, the protection is automatically lowered only to the extent that the sun does not exceed the maximum permissible penetration depth into the room. In the third case, we have it when the sun is very low. Therefore, the sunshade is automatically lowered and almost completely so that the sun does not shine too far into the room. This is also meant when we're talking about glare protection for the users inside. Any more questions about the shadow edge and sled tracking? It's quite hard words to pronounce, but it's not too complicated to set it up, and in the end it will make a very, very complete automation for the shading. I don't see any more questions, so we can continue with the next chapter. The fine adjustment for the optimum sled position. So first up, we need to determine what kind of sled type we're actually having. In order to do this, we can measure the width and, for example, the spacing. It's important to note at this point we can use the horizontal, but we can also use the vertical blinds to integrate into the facades. So both types of shading can be controlled, and that will help that no direct sunlight will shine into the room. The distance and the depth of the slab must be known so that the shading can be controlled directly. The width and the distance between the sleds are measured for exactly this purpose. The values must be then entered correctly in the parameter settings. Let me give you a little example what this actually means. So 95 is the slat width and 75 is the distance between the slats. Yellow is the sun's rays. So when the sun rises, the arrow moves inwards. No slat position necessary. When the sun sets, the slats must be adjusted so that the beam does not pass through directly. That's why we will need to calculate a little bit. This is the 75 divided by the 95. We want to calculate the angle, and this would come out to 38.2 degrees. This means that if the sun is higher than 38.2 degrees, the slats no longer need to be tilted. In Berlin, the sun, for example, is always higher than 38 degrees. It is between 135 and 225 degrees from mid-April. This means that the slat always remains at 0 from this point onwards. Let's discuss the slat position with the horizontal slats. The possible angle at the slat position is 0, but this depends on the mechanisms of the blind and the actuator. Shades that do not fold inwards are shown in 2 illustrations on the left. In the first illustration, we can see the angle of 90 degrees with a slat position of 0. In the second illustration, you can see the angle of 10% with a slat position of 100. Shades that fold inwards can be seen in the illustration in the right. Here the angle is, for example, 160 at 100% slat position. The angles must be measured with a protractor, for example, or obtained from the shade manufacturer itself. The values are determined and then entered in the parameters, as you can see on the bottom right. Let's have a look at the slat position for the vertical slat. So the possible angle at slat position 0 depends again on the mechanism of the blind and the actuators. Shades that do not fold inwards are shown in 2 illustrations on the left. Shades that fold inwards can be seen in the illustration on the above right. Here, an angle of 130 at 0% slat position will look like this. This must be measured once again with a protractor, or you can obtain those information from the shade manufacturer. The value determined are then entered in the parameters once again as displayed in the bottom right. How to actually set up the shadow edge and the slat tracking configuration we will show in a real example in the following video. As promised earlier, we're going to go in more detail over the sun protection position. As you can see here in this parameter, you have various options of selecting the solar protection position. You have without the tracking, slats in 4 stages, the slat tracking or the shadow edge tracking, or a combination of shadow edge tracking and slat tracking. For this one, we want to go big and gonna go for the shadow edge tracking and the slat tracking in combination. To set that up, firstly, you will need to measure the height of your window of the glass area. In this example, we can have a window with a glass height of 180 centimeters. Next up, we would like to define how much the sun can penetrate into the room. For this one, we will select 50 centimeters. The next parameter shows or says that if the shadow edge displacement is happening up to 10 centimeters, then the position will be adjusted. Here, it's very important to not go with a very small value because this will lead to a lot of hectic. So we can recommend with the default value of 10 might be a good starting point. Next up, it is required to measure how wide the slats are. In this example, it's 80 and the slat distance in between the different slats is 75 millimeters. Next up, you have the slat angle. So for example, you can have slats that open towards the building or outside, like sort of inverted. We had this earlier in one of the statistics. Depending on this, you either need a value of 180 degrees or respectively 90 degrees. And in the last setting, the slat angle, you know, even if it would be 0, it would not be closed entirely. So you will need to make use of the 10 degrees also. And there we have it. That's how to set up the solar protection position via the shadow edge tracking and slat tracking. Wonderful. I hope you enjoyed the last video. Now, as always, you have an option to ask some questions about the slat tracking. If I don't see anything coming up, I will continue with today's presentation. Maybe another remark. We are very well aware that it's kind of tough topics and a lot of information today, but that's also why we record everything and will upload everything on YouTube. So if you didn't understand something or we were too fast and for some topics, feel free to look it up on YouTube and you can rewatch the different videos as often as you please. And if that still does not help, the colleagues in the technical service are always more than happy to hear from you and to help you with your questions about automated shading with our KNX weather stations. So now we went through with the configuration of the facade, and now we can have a look at the fourth chapter and the protective function. And for this one, I will hand over to my colleague, Martin.
Okay, thank you. I think this chapter is a little bit easier because you know it already from the easier weather stations. So let's start with the basics. You should ask from your shade manufacturer because it's really depending on the details, on a specification, what kind of wind threshold you have to set. Every facade or every blind is different in size in everything. So it really depends on the facade shade manufacturer who gives you the details, and you can set the thresholds in the parameters in the ETS. Of course, you have to know what's the height of the shade and the mounting position of the weather station. So you have to make it clear before you start with the programming. Okay, this one is an overview of the wind speeds because it's well known that mostly it's given in meter per second, but sometimes you can find in the data sheets values in Beaufort or sometimes notes. Kilometer per hour is more common, but I think the most common is in meter per second. So with this table, you can refer the different values. Okay. Now I want to say you some words about how wind threshold value works. You can see this scheme, so I will show it with these lines and so on. The blue line is the current wind speed. It goes over the threshold value in the orange line. So in the parameter, you can set the threshold value, and when the wind goes up over this value, the blinds would move. When you don't make a delay in seconds, we have a short video after this, so we can show it in the parameters. You make this delay because you don't want to go to let the shades go down or in the shading position immediately. And you don't want to go them up again when the wind goes down the orange line. So you have to make a hysteresis, and this the hysteresis is in the orange dashed line here. So, and then if the wind goes down, the hysteresis, you don't want them to go up really early, because it's perhaps it's only a cloudy day and a windy cloudy day, and so it's really annoying when the shades go up and down the whole day. So with these delays and the hysteresis, you can make a smooth blind automating. Okay, now it's about the wind direction. This to setting the wind direction threshold values is not integrated into the facade, and it must be integrated by input objects. Okay, there are some mistakes you can do when you get your weather station on the roof. For example, here's one error case. The problem is exhaust air from the air conditioning system distorts temperature and wind measurement. You can imagine, so the wind values and direction are not correct if the exhaust air is blowing in this direction. So, but it's a easy solution. Just install it out of reach of the system that cause air currents or waste heat. Another error case, you can see it. The problem is impairment of brightness measurement due to self-mounted bird protection. So can be a nice idea to avoid birds, but as you can see, it's not only for design. We have many objects and sensors in this design. It's no spaceship. We need the space, and if you make the bird protection over it doesn't work properly. Easy solution: neither objects, no other structures may cast a shadow on the appliance. Okay, now let's take a look at the settings for the wind direction threshold values. Here you can see, here you can set whether the values received via a communication object should be retained after voltage recovery plus reprogramming, or lost. In the next section, the range specification can be specified by the parameters, fixed values in the application, or via a communication object, for example, a visualization. In the next step, as mentioned, a hysteresis must be set. The hysteresis is the switching threshold between the range exceeded and no longer exceeded. The third one, in the next setting range, we can set a display from a delay time from 0 to 1 and from 1 to 0. This one. We command always setting a delay here, for example, from 0 to 1 for 2 seconds or 5 seconds, and from 1 to 0 of about 5 minutes or even longer. I would expect 10 minutes. This means that the wind direction must be fulfilled for 2 seconds for 1 to be sent on the bus. If the wind direction is no longer fulfilled for 5 minutes or 10 minutes, a 0 is sent to the bus again, for example, to enable shading again. There is also a setting for how the switching output should be sent. This one. For example, on change and cyclically, including an adjustable sending cycle. The output of the threshold value can be deactivated, blocked via blocking object if required. So now it's about setting the wind threshold values. The setting of the wind force depends on the blind used and the type of construction or positioning on the object. The maximum wind value must therefore be requested from the shading manufacturer, as mentioned before. We have already discussed the first point as one that the threshold values received via the communication object should be retained with the wind direction threshold value. The wind threshold value can be specified via the parameters, fixed values in the application, or via a communication object, for example, via a visualization. In the next step, hysteresis must be set. The hysteresis can be set in %, as you can see here, or as an absolute value. The hysteresis is the switching point between wind value exceeded and undershot. Example. In our example, we have set 8 meters per second as the wind threshold value. If the wind value of 8 meters per second is exceeded, the alarm is sent to the bus. If the wind value falls below 8 meters per second minus 2 meters per second hysteresis, the alarm is deactivated and a 0 is sent to the bus. In the switching output settings, we can set how the switching output should work when the threshold value is exceeded. This means, for example, that we can select whether a 1 or a 0 is sent when the limit is exceeded. A switch delay can also be set. A switch on delay 0 to 1 is recommended so that, for example, small wind gusts are faded out and a switch off delay 1 to 0, so that it is only extended again when there is no wind for a longer period of time. More on this later. We can also define how the switching output should be sent, for example, cyclically or on change or both, as well as the cycle time. You can see it there. The third box, in the first step, we can specify whether we activate the lock with the value 1 or 0. In the second step, the value of the lock is defined before a communication object is sent, for example, whether the lock is active or inactive after reprogramming. And in the last setting, we can specify whether we want to send a specific value when blocking. For example, block active means wind alarm. Okay. More values for you. Setting the wind threshold values in the facade control system. The following parameter settings can be found under facade safety, where the wind alarm for the facade automation can be set. We always make the path in the ETS, or where you can find it in the ETS in these slides as well. So here you can set how the wind alarm and, if desired, the wind extension lock are set. In my example, I use the wind alarm by threshold value. As I'm using the wind value measured by the weather station, I have selected the measured value from the internal sensor. If there are individual wind sensors on the building, for example for the facades, these can be integrated via a communication object. In this case, the measured value of the internal sensor would be set to no. The measured value of facade 1 wind is activated instead. The following object would then receive the measured wind value from the external single sensor of the facade. You can see them here. A maximum of 12 individual sensors can be integrated. In the right-hand window, we can still see the setting of the wind threshold value. Okay, there's the possibility to add wind sensors. So, for example, as you know, we have our KNX WSL. You can see in the picture. And as Bastian mentioned before, you should use them if you have, for example, more than 3 stories. Right. Okay. Now we make a video, we show you a video about this topic.
In the following video, we would like to integrate an external wind measurement sensor, and you can do this as followed. First of all, we are in the facade section. Next up, we're going to click on the facade 1, the function and safety settings. Here at the bottom, we would like to use the wind alarm, and in this example, we want to control it via the threshold value. So here in this settings, you can decide if you would like to have the internal sensor that is built in our Suntracer Pro. For this example, we do not want to use this. You can think about a huge building, for example, that has facades that are very far away from each other or very high, and the wind measurement sensor is not close to the facade. That's the use case when you would like to use an extra external wind sensor, and that's what we're going to do exactly here. So we set no to the internal sensor measurement, and we allow the measurement via communication object for the facade 1. Next up, we can set the threshold. This means if the wind is stronger than 8 meters per second, then we will go in a safety position. We want to do this with a little delay here in seconds. That means the wind threshold value has to be overshot by 2 seconds in order for the blinds to go in safety position. Okay, now that we have set up the threshold for our wind value, next up we want to set up the live monitoring. This is the parameter you can see here, and we simply tick the yes here. I think the default value is 5 seconds, but we strongly recommend using a setting of 30 minutes, because that will mean if they do not get a reply within 30 minutes, that means something is going wrong and the blinds can go in a safety position. Why we use 30 minutes, I will explain in a second. For this purpose, we will have a look at the external wind sensor that we have integrated, and therefore we go on the wind measurement. The transmission behavior, we want to send it on change and periodically, and we want to have a send cycle of 10 minutes. This allows you for a relation of 1 to 3, meaning within half an hour 3 replies should arrive, and if they don't show up, then the blinds should retract in the safety position. This is how you set up the live monitoring. All right, the last thing we need to do is simply to link our group objects. As you can see, we are here in the group object section. Down here we have the group address for the wind measuring value 1. We can drag and drop this to the wind measurement value. And the last thing we need to do to integrate an external wind measurement sensor is to take the facade wind measurement and also connect it to the wind measuring value 1. And that's how simple and straightforward you can integrate an external wind measurement sensor to our Suntracer Pro KNX.
Okay, I think these videos were quite helpful, so we can go further. Further protective functions. Okay, there comes the word from. Okay, as you can see, always the path in the ETS as mentioned. And now it's about protecting the facade. Earlier we discussed the wind alarm settings, and now the facade automation offers further protective functions. For example, the frost alarm. If the outside temperature falls below 2 degrees during or up to 5 hours after precipitation, the frost alarm is activated and the shading is retracted. Rain alarm. In addition, a rain alarm can be activated for fabric shades, which moves the drive to the safe position in the event of rain. The automatic rain function causes the blinds to extend when it rains so that they are washed, cleaned by the rain. And here you can see the frost parameters. Okay, as explained in the video before, it was for the external parameters. Of course, you have to make the monitor or the live telegram monitoring with our main weather station, our Suntracer KNX Pro, and the blind actuator as well. Because if these signals are missing, the actuator detects a failure and can, for example, raise the blind automatically for safety reasons. And why are the signals missing? It can be a broken wire, it can be a misfunction on one of these devices, or misfunction of the line coupler, as well as some kind of other products that are causing failures on the KNX bus. And we have, especially for this, another video.
Okay, now we're gonna set up the live telegram monitoring, and to do this, first up we need to change the transmission behavior for safety and alarm status object. So now the setting is set on change, but in order to do a live telegram surveillance or monitoring, you need to do it on change and periodically. We would like to have a send cycle of 10 minutes. Next up, we're gonna have a look at the actuator. And in the actuator, we will need to go to the outputs. We will say the blind is used, and then the output channel A, the controller, and here we can see the use monitoring of the blocking objects. Here the default is no, but for this example we want to say yes, and we want to monitor a period for blocking objects for 30 minutes. Remember in the settings before, we set the 10 minutes, and this is, once again, as in the last video, this is the relation we recommend. So within 30 minutes there should be 3 times where a value is being tried to send, and if this value is not received within 30 minutes, the blinds need to go in safety position, and this is exactly what we set up here. We do the up command, meaning our blinds will go in safety position if a wind alarm is triggered within the 30 minutes. If no wind alarm is triggered, they will go up in the safety position as well. Of course, that's exactly the live monitoring that we just set up. Okay, one of the final things we gotta do is set up the use block, so we have all the objects for linking. The use block 1 with a high priority we do not use, since it's mainly used for smoke detectors or alike. We will use the block 2, and we will set it up as a wind block. Perfect. Next up, we're gonna connect the group objects to each other. Therefore, we take the wind alarm from facade 1 and connect them to the wind block object. Next up, we're gonna go in the Suntracer Pro objects. There we're gonna look for the wind alarm status output, and we also gonna link it to the wind alarm of facade 1, and there you have it. That's how you set up the live telegram monitoring with an external wind sensor.
Okay, in this part, do you have any questions? Of course, we give you a few seconds and watch if anybody needs help. Okay, no questions left, so we can go forward to energy saving through intelligent parameterization. And first of all, we come to our pyranometer. I don't know if you know it. It's an external device not integrated in the Suntracer KNX Pro. What can you do with it? It's for measurement of the global radiation. It's recording the current irradiance in watt per square meter and the energy input over time in kilowatt hours per square meters. And both values you can parameterize in the ATS and get it out on the KNX bus. Okay, for what do you need it? For example, if you don't only want the shades going down or the blinds going down because of the brightness and, for example, outside temperature, but you want to integrate the solar input as well, and then you can use this pyranometer to save more energy. And it's necessary for comfort certificates according to the mentioned norms. And as we know, in Switzerland, Luxembourg, for example, it's recommended that you have to use it in special buildings. Okay, in the parameters, you can set it via the communication objects 338 until 645. So you can see it here, what you can do. Of course, as like you know it from the wind sensor, there's a threshold value for the pyranometer input. You can use the hysteresis, and you can say, okay, in which direction or which position has the blinds to move. You can make a delay in minutes. So these parameters are nearly similar to the wind parameters we had before. Okay. Automated ventilation is only enabled automatically when the outside temperature is appropriate. This helps to prevent the building from cooling down in cold temperatures. The implementation is possible via a temperature threshold value that blocks the ventilation. So I mentioned it before. You have many values you can integrate in your shading or in your automatic shading, and the temperature is one of it. And the advantage is, of course, reduced heat loss, heating costs are lowered. Okay, once again, the question, if you have any questions, just write in the comments or in the questions section. Okay, no questions so far, so we can go forward. And I head over to Bastian again.
Thank you very much, Martin. So in the previous chapter, we looked at the settings for the automatic sun shading system. To do this, we dealt with the defining and alignment of the facades, and we got to know the shadow edges and the slat tracking and defined slat distances and angles. At the end of the chapter, we learned about the alarm functions and the status output of the automatic facade control. Next up, we will have a look at the installation and troubleshooting. So to activate the facade status object, the Suntracer contains a status output of the facades via communication objects. The status message of all facades can be viewed via the status output X that you can see here. You can then use the plus and minus to scroll through the individual facades to query an status output. The same objects are available as individual status messages for each facade. These are called facade 1 channel status output. We're gonna have another look at a quick video on how to actually set that up. In the following, we have a look at the output objects provided by our Suntracer KNX Pro application. Here you can see the different output objects that you can name according to how you need it with a 14-bit object that is allowed. Next up, we're gonna have a look at the group objects. Here you can either look for the output objects for facade X, which are those here, and they would allow to get the outputs from facade to facade. So you can switch from one to one of the other 12 facades available in the Suntracer Pro. There's another way of doing this. You can also do it from per facade. That's when you simply take the status outputs as here, and you can do it one facade after another. Okay, here you can see the group addresses we linked to each other earlier, and now I have started the bus monitor already, and we would like to get the status of facade 1. Therefore, we go to the facade X channel status output. We use this group address 002, and we need to send the value on, so it starts sending, and we use the writing function, and as you can see, we are receiving the first values from our Suntracer KNX Pro. As mentioned earlier, the facade X is responsible for all the other facades, meaning we can switch to other ones also. In this example, we only set up one more facade. This is the east facade, and therefore we use the group address to switch the channel, and once we start writing, we can hop from one facade to the next one. Here you can see the values from the east facade, and we can switch back to the south facade. And that's how you set up the monitor and check the values of the different facades. Okay, here you can see the group addresses we linked to each other earlier, and now I have started the bus monitor already, and we would like to get the status of facade 1. Therefore, we go to the facade X channel status output. We use this group address 002, and we need to send the value on, so it starts sending, and we use the writing function, and as you can see, we are receiving the first values from our Suntracer KNX Pro. As mentioned earlier, the facade X is responsible for all the other facades, meaning we can switch to other ones also. In this example, we only set up one more facade. This is the east facade, and therefore we use the group address to switch the channel, and once we start writing, we can hop from one facade to the next one. Here you can see the values from the east facade, and we can switch back to the south facade. And that's how you set up the monitor and check the values of the different facades. Okay, now we're gonna have a look on how to do it if you want to have the status output, for example, for a visualization. For this purpose, we can use the group address 009, the facade X channel with the status bit selection. Therefore, we go to the bus monitor, we hit the right group address, and we use the writing function. And as you can see, all the alarm objects are triggered now. For example, the rain alarm, which is off. Next up, you can see the frost status, which is off also. You have the wind alarm, the auto block, for example, the brightness and the longitude, and so on. This is very useful if you would like to display the status selection on a visualization. Okay, we continue with our topics. Let's discuss the simulation objects. So in order to simulate weather data, it's very good to have a testing system without the actual real weather conditions. This is exactly what you can use the simulation objects for. Therefore, you can do a manual specification of sensor values in order to try the system. This is ideal for commissioning, testing, but also for troubleshooting. You can do the activation of this via communication objects in the ETS, and how to do that we will show in the next and last video. In the following, we're going to have a look how to use the simulation object in the KNX Suntracer Pro. First up, in the global facade settings, you need to activate the use of simulation objects. Next up, you need to go into the individual facade and activate those simulation objects. I have done this in advance and also linked the group addresses to save a little bit of time. Next up, you can use the filter function quite well. I just typed in sim so I can have a look at all the simulation objects. And before we can go on with the next step of the simulation, we will need to use the facade 1 simulation object and send a 1. Okay, we have started the simulation again. And first off, we need to start the simulation objects, and we're going to do this with the group address 016, where we need to send a 1 on the bus to start the simulation. In the next steps, we will go from one object to another one and give them a value. For example, here 0 meters per second. In the wind blocking object, we will just use the off. For the wind alarm, we will keep it as off also. And we continue from one group address to the next one. This is all just very basic examples. Where it's going to be quite interesting is going to be in the following objects, where we will give the time and date, which we will do in a second. Now, here we can set today's time and date. And with the help of those values, the weather station can already calculate the position of the sun, and you can see in the simulation how the blinds would move accordingly. Next up, we change the value. So here we can see the blinds are now closing off, and you can see the angle of the sun has changed accordingly. And we can change it back again, and we see the former value. With the help of the simulation that I have just presented, you can check how the facade will behave according to different values that are perceived by the sensor. This is good to check the feasibility and if the programming of the facade is correct. Okay, we are on the last stretch of today's webinar. Any more questions about the contents we just discussed? I cannot see anyone typing, so we will continue and hopefully we'll make it in the time as announced in the beginning.
Okay, now we want to show you how to integrate further facades. As you know, our Suntracer KNX Pro can manage up to 12 facades, but if you have more, you can see here our BX8 KNX blind control extension together with with the SL. This one or these two devices you can use for extend your facade automation. So, and it's with the 12 of the Suntracer Pro, more 8 with the BX8, you have 20, but it's not the limit. So you can use several BX8 controllers to make a huge facade control. Of course, it includes the rain, wind, and frost protection. It can include the pyranometer and so on. So every device matches together of our extensions. Okay, this is an overview. On the left-hand side, okay, there is the weather sensors, or for example, the Suntracer Pro, but as well as mentioned before, the Suntracer SL. And they send on the bus daytime, precipitation, wind speed, and so on. And the BX8 uses them to make the automating control. And it sends the values on the bus to go to the actuators. And as the Suntracer KNX Pro can, the BX8 is it's possible too with it to make many texts and values going out on the bus to use it in the building management system. That's a very nice tool. Okay, now we come to the end, and I can say goodbye from my side and give the words to Bastian again.
Wonderful, perfect. Thank you so much, Martin. So today we went over many topics that we could not really cover yesterday. We started off with a model comparison and the function overview. We discussed the functions and the very special features of our Suntracer KNX Pro. We discussed the parameterization of the facade automation and showed a lot of ETS extract and recorded some videos beforehand. Next up, we discussed the configuration of the protective function, rain alarm, frost alarm, and precipitation protection. Next up, we discussed how we can actually save energies through intelligent parameterization. And afterwards, we discussed the commissioning and the troubleshooting. In the last part that Martin have just presented, we discussed the integration of additional facades if you're running out of available facades in the existing sensor that you are using. And here we are at the end of today's webinar. It was quite an effort to prepare all that. It's not an easy one to present, but we truly believe it's very helpful and we can have a lever for more energy efficiency and really take shading with KNX on a new level. That's what we're working on, and that's the mission we are on. Therefore, we hope the contents today was not too much for you. As always, we love to receive feedback from your end, not only the positive ones, especially the negative ones, so we can try to give you a better edition of a similar webinar in the near future. We recorded today's webinar, so everyone will appear in just a couple days on our YouTube channel, so you can re-watch everything. Additionally, if you have registered to today's webinar, we will send out the presentation as a PDF. Here on the last slide, you can see my contact details and also the details of Martin. Feel free to drop by on our LinkedIn channels. We try to give some looks behind the scenes of what we're actually doing here at Elsner. And of course, if you have some technical requirements, some questions, feel free to reach out and we will do our best to help you. Also, if you're interested in consulting sessions on which model might be the best for you, we are happy to help and consult in those matters. That's it from my end, I thank you very much for attending today's webinar, and I'm already looking forward to the next English speaking session after our summer break, which will be by the end of August, if I'm informed correctly. But as always, we will share the information online and also send out some newsletters. Thank you very much, and goodbye from my end. See you in the next session.